talk about real zeros of polynomial functions, and right now we are just going to introduce or review, I suppose, from last year, long division and its purpose. Long division is used to find factors of polynomial. Division and factoring are the same process. Sometimes we can use what is called synthetic division, which is a scaled down version of long division. And today we will also touch on the remainder theorem. First of all, let's review long division. We have 2x to the fourth minus 3x cubed plus 5x minus 1 divided by x minus 2. So I am going to put 2x to the fourth minus 3x cubed. I am going to write 0x squared. That's important that we hold a missing place value, and since there is no x squared term, I'm going to write 0x squared plus 5x minus 1 divided by x minus 2. And this process is similar to when we did long division in elementary school, where really we take a look at the first terms and we divide them. 2x to the fourth divided by x. Or you can ask yourself, x times what gives me 2x to the fourth? So this is 2x to the third and so then I multiply 2x to the third by these two terms. That gives me 2x to the fourth, and then 2x to the third times negative 2 is negative 4x to the third. So then we need to subtract this line. So very carefully, if I would subtract this line, I would need to subtract each term. So we have 2x to the fourth minus 2x to the fourth, which is 0. Negative 3x cubed minus a negative 4x cubed, which is negative 3x cubed plus 4x cubed, or 1x cubed. And then I drop down the next term. I then repeat the process. I'm still dividing by x minus 2, and now I take this row and divide by x minus 2. So x cubed divided by x, or x times what gives me x cubed? The answer to that would be plus x squared. And so then I multiply. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. And I subtract the row again. So x cubed minus x cubed is 0, but a 0 minus a negative 2x squared gives me positive 2x squared. And then I drop down the plus 5x. And once again, how many times does x go into 2x squared, or what is 2x squared divided by x? Whatever way you prefer to think of it. This should be a plus 2. 2 times 2x. 2x times x is 2x squared. 2x times negative 2 is negative 4x. We subtract one more row. So we have 5x minus a negative 4x, which leaves me with 9x minus 1. And so 9x divided by x is 9. 9x minus 18. I subtract the row, and I am left over with negative 1 plus 18 with a remainder of 17. Or another way of writing that, then, is this quotient is 2x cubed plus x squared plus 2x plus 9 plus a remainder of 17 out of x minus 2. When we have numbers that we divide, that's how we leave that. And on your worksheet today, there is also a summary statement that I show you how to write. So, for certain divisors or factors or terms, we can use something called synthetic division. And in order to use synthetic division, we have to have a linear factor, and so by linear factor I mean degree 1, so in the form x minus k. And so what I have is the same problem, and I'm going to show you how it would work with synthetic division. So when I'm dividing by x minus 2, it's got to be of the form x minus, I actually put a 2, not a negative 2, in this little corner box here. And I put what I'm going to divide, or my numerator, I put the coefficients in a row. And so we have 2x to the 4th, a negative 3x cubed. Remember, there is a not an x squared term, so I have to put a 0 there to hold the spot. And then a 5x, and then a negative 1. And so really what we do is we save a lot of space this way, and we make the process a little easier. Here, instead of having to subtract, because sometimes that leads to some computation errors, because this is a positive 2, that takes away that subtraction piece, and I can now add. So I always drop down this first value, and then once it goes below the line, I multiply by what's in the box. So 2 times 2 is 4, and then the 4 goes here. And then I add. What's negative 3 plus 4? It's 1. Then 1 times 2 is 2. What's 0 plus 2? It's 2. Then 2 times 2 is 4. 5 plus 4 is 9. 9 times 2 is 18. Negative 1 plus 18 is 17. And so then I go back and put the variables in. And remember, I just took an x to the 4th divided by an x. So if I took an x to the 4th divided by an x, the degree is going to be an x cubed. So 2x cubed plus 1x squared plus 2x plus 9, and this last term is a remainder. So notice I get the same thing above as above, which I should with synthetic division. Just keep in mind that if this factor, the thing that you're dividing by, is something that's x squared or x to the 3rd, you cannot use synthetic division. It has to be just x minus some number, some linear factor. Okay. So I want to just point out again how we find remainders, a shortcut for finding remainders. In both of these methods, we had to wait till we got to the way end of the problem to determine what the remainder was. Okay, it was 17. Let's evaluate f of x equals 2x to the 4th minus 3x cubed plus 5x minus 1 when x equals 2. Another way of writing that is f of 2. So let's do that. Alright, so we have 2 to the 4th. We're going to do our powers first. 2 to the 4th, which is 16. We're going to have 2 times the 16. We have 2 cubed, which is 8. So minus 3 times 8 plus 5 times 2 minus 1. Next, we'll do our multiplication. So 2 times 16 is 32 minus 24 plus 10 minus 1. 32 minus 24 is 8. 8 plus 10 is 18. 18 minus 1 is 17. So what do we notice? This looks familiar. Well, it should look familiar. So when I plugged in 2, and by the way, 2 is the same thing that I see here. I see x minus 2 and x minus 2 up here. When I plugged 2 into the function, I got a remainder of 17, or f of 2 equals 17, excuse me, that's the same as the remainder above. Is that a coincidence? No, it is not. So there's this thing called the remainder theorem. We'll talk more about this tomorrow. If a polynomial is divided by x minus c, so c is some number, in this case up here it was x minus 2, the remainder is the same as the function value f of 2. So, what have we learned? When a polynomial is divided by x minus c, there's kind of two long ways we can find the remainder. We can find the remainder using long division. We can find the remainder using synthetic division. But in both of those cases, we had to wait till the end. We can find the remainder using f of c, which is the remainder theorem. So hopefully this was a good review of the ways that we can divide polynomials using long division and synthetic division, and then the relationship with remainders and those things.